Hi, Sharon Sarago here, and today we're going to talk about squares and square roots. I know that you've had this before, but a lot of times it's so far removed that some of my students have trouble with it, so I wanted to go over it real quickly. You will need to know the squares of the first several integers. They are going to appear on both the SAT and the PSAT, and you do not want to reach for your calculator to get to those. So here are the first 8, and you probably know all of these, but then you should go ahead and learn all the rest of them up to 13 squared is 169. Because, as I said, this is a time test and you do not want to rely on your computer for it. Your calculator. You want to get these common squares memorized because you will definitely see them over and over again on the test. Remember that the square of a number is simply that number times itself. So if we have 4 times 4, we would write that 4 squared, and of course it's 16. I want you to think about this, because now we're dealing with negative numbers. If you have a negative 4 squared, is that any different from just plain squared? So when you think about that, what happens when you take a negative times a negative? It becomes a positive, doesn't it? So it would be the same. Remember those things, that's going to show up. Now, finding the square root of a number is actually the inverse operation of squaring that same number. So the square root of 16 is the number that gives 16 when it is multiplied by itself. And of course you know that 4 times 4 is equal to 16. Let's say that on the test you encounter a problem involving square roots, such as the square root of 25. In this case, you need to know the squares in order to take the square root. And that's why we want you to memorize it. So since 5 squared is 25, then the square root is 25. There is a time and a place to use the calculator, but this is not it. You have to know these numbers and commit them to memory. And please do not forget that on your new test there will be 2 separate math sections. One, you will be able to use the calculator, and on the other, you will not be able to use it. Remember, the symbol that we use for finding the square root is this. However, just as we can raise a number to powers other than 2, we can find the cubed root of a number, or the 4th root, or so forth and so on. So while this thing right here indicates the square root, we have other ways by using that to indicate other roots. So for instance, we have 2 cubed, and that's equal to 8. That's the same thing as 2 times 2 times 2. And then we could have the cubed root of it. Just notice where we put this 3. That means the cubed root of 8 would equal to 2. I want you to just be sure that you understand that 3 times the square root of 8 is not the same thing as the cubed root of 3. They are very different. It's all a matter of where you put the index, the number indicating the power of another number. So let's look at simplifying square roots. At some point, you may need to simplify a square root other than the perfect squares that you memorize. The ones you already know are easy. The square root of 4 is equal to 2 squared, which is 2 times 2, and of course that's 2. Notice how we broke that up. Whenever you have a pair of numbers, they can be taken out. So if we have the 2 times the 2, that's our pair, and so that can be taken out from under this radical. Now let's simplify the square root of 75. 75, we know we could break it up to 3 times 25, and what we're looking for is a perfect square. Now once we know that, we can separate those into 2 radicals. Square root of 3 times the square root of 25. And since we know that 5 times 5 is 25, still under the radical, and that simplified becomes 5, taking the pair out, 5 times the square root of 3. As you can see, you take out the perfect square, put it in front of the radical, and then leave everything else like it was. You can simplify variables in the same way. So if we had the square root of 9 times n to the 4th power, that's going to be the same thing as 3 times 3 for 9. And n to the 4th, of course, would come from n squared, right? So we'd have n times n times n times n, and that would be n squared, take out from the radical. So we have 3n squared. Just remember to take out the pairs. Now, when we are adding and subtracting square roots, we have certain things that we want to do. You can add and subtract square roots only if the radicals are the same. So we have 3 times the square root of 3 plus 4 times the square root of 3. Well, we can do that because we can add 3 plus 4, and that would be 7, but we're not going to change the radical. So we've got 3 plus 4, still times the square root of 3, and of course that equals 7 times the square root of 3. Here's another example. We have 3 times the square root of 3 plus 4 times the square root of 2. Now this is not the same. You can only add these if the radicals are the same. Here we could add them. Here we cannot. And then plus radical 3, which is the same thing as 1 times the radical 3. So we can combine this one and this one, and we get 3 plus 1 times radical 3 plus 4 radical 2. And so our final answer, after we simplify it all, would be 4 times the square root of 3 plus 4 times the square root of 2. These two things cannot be combined because they're not the same. You can always simplify. 2 times the square root of 9 plus 4 times the square root of 5. So if we simplified this, it would be 2 times the square root of 3 times 3 plus, then we're going to break this one up, 4 times the square root of 5 times 5. That would give us 2 times 3 right here, plus 4 times 5. And of course that would be 6 plus 20, which would be 26. Here's another example. If the square root of 48 is equal to x times the square root of 5, and x and y are both integers, and x is greater than y, then x is equal to one of these things. First thing that we want to do is to break that 48 into a perfect square times another integer. So you look at 48 and you say, is there a perfect square in this number? Yes, there is. 3 times 16 is 48. So then we're going to break that single radical into its two constituent parts. So instead of having 16 times 3 under the radical, we'll break it into two of them. And we would say the square root of 16 times the square root of 3. Then, of course, we can take this out. Simplify the radicals. We know that x is equal to 4 and y would equal to 3. They did not ask us about the radical. They just said x and y. What are those? And so they wanted to know what x is, and our x was on the outside of the radical, which would be 4. Here's another example. Points A and your coordinates are -2 and 1, B with coordinates of 1 and 1, and point C with coordinates of 1 and 5 form the vertices of a right triangle. So here it is. We've got points A, B, and C. We have a right triangle here, and we've put those points down. Now on your paper, anytime you draw the XY coordinates and you're putting points, I want you to put the points out there by that, because whenever we are given things like this, we're going to have to use those coordinates for calculation. Do not try to remember them. Don't go back and look at them. Just go ahead and very quickly write them beside your A's, B's, and C's, and then you'll have it there and you won't have to worry about it. Now our question says, what is the length of side AC? Right here. Alright, so we've got the picture so that we can visualize it, and you must always draw a picture so that you can see what you're doing. Once you have the points graphed, you can easily see that the length of leg AB is 3, and the length of BC is 4. If you call the length of the hypotenuse AC by a variable, say x, then you could use the Pythagorean theorem and have the equation a squared plus b squared equals c squared, and you would have 3 squared plus 4 squared is equal to your hypotenuse x squared. Simplify the left side, of course, and you would have 9 plus 16 equals 25, and therefore 25 is equal to x squared. But that is not what the question asked. They wanted to know what x was. And so we would have to take the square root of that. Get rid of this square here by taking the square root of it, which means we have to take the square root of both sides. So if we knew that 25 was x with a very large 2 for squared, take the square of both sides, we would find that x is equal to 5, which would be our line AC. I want you to remember that a potential answer of x minus 5 would not apply in this problem because we're looking at the distance of that line, not a point of that line. And of course the distance always has to be positive. Now, for those of you who learned the triples from our last lesson, you wouldn't have to go through this because you would say this is 3, this is 4. Oh, then if it's a right triangle and I have 3 and 4, this has to be 5. This is why I want you to memorize those triples so that you don't have to go through this. But of course, if it wasn't a triple, now you know how to do it. And then we have example number 3. For all values of x where -2 is less than x, which is less than 0, which of the following statements is true? Alright, so let's just look at this one by one. We already know that x has to be a negative number because they said that x was less than 0. And we can conclude that even powers of x, x squared, x4, etc. will be positive, and odd powers, x to the cubed, x to the 5th, will be negative. So we could immediately eliminate choice E. If you consider the values for x in the specified range, you can check the validity of the other statements. In choice A, if we say x is equal to a -1, the statement is true because a -1 squared is still 1 and a 1 to the 4th power is still 1, so that would be true. But they did not tell us that x was a -1. They said it was simply less than 0. So what if it were a -0.5? Then that statement would not be true. And since the question asks for all values of x, we have to eliminate choice A. On choice B, if x is -1, then x to the cubed is greater than x is not true, and that's what it says. It would still be negative. A -1 cubed is still -1. Thus, choice B must also be eliminated. In a similar way, choice D can be eliminated because x squared is less than x to the 4th power is not true if x is equal to -1. In that case, a -1 squared equal to a -1 to the 4th power is 1. Since all of these choices can be eliminated except for C, you can confidently choose C for your solution. Notice that in the statement for choice C, x squared will always be positive and thus will always be larger than x cubed, which would be negative. Alright, so you're going to have some practice problems. I want to talk to you about this first one because it uses what we call weird symbols. This doesn't mean anything. It's something that the College Board just makes up. But they said let the operation crosshatch, I'm just going to call this sign, be defined for all values of x and y, where x is larger than 0, as x and this stuff, y, is equal to this. So this is your definition. Anytime you see this, it means this. Y squared divided by the square root of x. So if I had numbers here, if I had 2 and 4, then wherever the x is, it's going to be a 2. So that would be the square root of 2. And wherever the y is, that's going to be a 4. So it would be 4 squared. Now this is how it works. And you're going to see problems like this on your SAT test for October, November, December, and January. Likely in 2016 they will stop using these problems that deal with weird symbols. But right now you have to know how to solve it. So your question is, which of the following values will x sine y be an integer? And you can go through there and look at these. Well, if you look at this, they're asking for the square root of x right here. And they said that whatever you choose, it has to be an integer. You know what that is. It's a whole number. And so if I chose the square root of 30, is that going to be an integer? If I choose the square root of 36, is that an integer? So can you see that just from this definition right here, I can eliminate 3 choices. The only one that I could possibly have there would be A or B, because these are perfect squares. And the square root of x then would be 5 in both of them. So now I just have to decide, if I perform this operation with both of these numbers, which one is going to give me an integer? So if y were 1, that would be 1 squared. And that would ultimately be 1 over 5. That's not an integer, it's fraction. Let's try this one. If I put y is equal to 10, I put 10 squared, that would be 100 over 5. 5 will go evenly into 100, and that would give me an integer. All right, and then your second equation here. You're going to have a whole lot of practice problems on these square roots. So on your printed materials, I want you to work through all of them. Again, if you have any trouble on any single one of them, mark it. You can put a question mark or something on the side of it so that when we meet on our meetings, our webinars, then you'll know exactly which one you need to go to and ask about. So just understand that this is something you learned a long time ago, but the review is very, very critical. So get all of the problems done, and then we will talk about it in a day or two to see if there was anything that you need to have further clarification on. I'll be seeing you in a few days then.